Good morning, everybody. Happy snow day. So we did a lot of this in class yesterday, but we do need to finish it up. And then you need to work on your 4.5 practice assignment today. So if you remember, we learned how to write our equations for this. We did the different pieces, right? We did 5 goal meetings, 2 application meetings, and then we know that they totaled to 165 minutes of the day. And so we wrote that using those. So we said 5G plus 2A was equal to 165 minutes. Then we did some of this. I'll post those complete notes for you guys. And then we did it again. We did these ones with, we said 10 goal meetings and 4 application meetings. And that one took up 330. And so we did some work with that one, and we said 10 goal meetings plus 4 application meetings needed to equal 330 minutes. And we looked at the possible combinations of meeting lengths that we used in questions 1B through D and checked to see if they worked. So we tried like this one, and we figured out that if goal meetings were 25 minutes in this case, we would do 10 times the 25 plus the 4A. And we checked if that equals 330, how much would the application meetings be? So we went ahead and did this. So 10 times 25 is 250. Plus 4A is equal to 330. And then if we minus the 250, we get that 4A equals 330 minus 250 leaves us with 80. We divide by 4, and we got that the A needed to be 20. And sure enough, if you have your notes written down from this one, that was also if G is 25, then A was supposed to be 20. So that's the same thing that we got before. And then we checked some others, and we figured out that every single one of them works the same way. So then I wanted you to look at this and solve the system, but with the equations. So we took a look at this equation. And then we also took a look at this equation. And I wanted you guys to see what you noticed about these. So hopefully you guys were able to register. It doubles. That second equation is exactly twice as big as the first one. So if you were to try to solve these ones algebraically, you would run into problems every single time you tried to do it. Because there's kind of 2 ways. If we tried to do it by elimination, this is the way I want to focus on. In order to do elimination, we would have to have 2 of them that match. So in order to get 2 of them that match, we would times everything by 2, right? So then we'd have 10G plus 4A equal to 330. And then if we try and eliminate what's the same, well, that's the same, and that's the same, and that's the same. And everything gets eliminated. Which is a problem, because now how do we solve then? How do we deal with this? Okay. So the reason is that these are actually the same line. These are the same line. The only difference is that one has been doubled. And when that happens, it's telling us that it's the same line. So It is getting close to the end of the school year. The guidance counselor needs to schedule 15 goal meetings and 6 application meetings in 480 minutes. And we want to know, is that possible? Okay, so let's check. If we had let's do this. Let's go ahead and use this top one. So if we want to have 15 goal meetings now and 6 application meetings, then this would be in the minutes. So I hope you guys notice that to go from this 15 to this 5, or vice versa really, to go from the 5 to the 15, we would need to times by 3. And to go from the 2 to the 6, we would also need to times by 3. So that should mean that to get the minutes, we would times by 3. So if we do that, if we go through and we times everything by 3, we would get 15G plus 6A, and it would need to equal 165 times by 3. Okay. Whatever that comes out to equal. So if we actually do that, if we actually put 165 times by 3 in a calculator, or I'm just going to do it like this really quick. So it should equal 495. So what we notice is that 495 is not the same as 480. So can she do it in 480 minutes? No. It would take 495 minutes, not 480. Okay. So we are going to go ahead and move on to this back side. And we are going to take some quick notes here. So, when we're doing these quick notes, I want you guys to copy some information down. Alright. So if a system of 2 equations has one equation that is a scaled version of the other, there are infinite solutions. The reason for this is that they are the same line. So just wanted to make sure you guys know what this means. So scaled means that one equation is the exact same thing but multiplied by all the same number. So when I say scaled, I mean we took this whole equation and we times the entire thing by 3 and got 15G plus 6A equals 495. Or we took the entire thing and we multiplied by 2 and got 10G plus 4A equals 330. Okay, so scaled means that everything in it has been multiplied by that same number. Okay, So when it's scaled or multiplied, when it's a scaled version or a multiplied version of the other, there are infinite solutions. So I just want to make sure you guys know, scaled means everything multiplied. Okay. The second piece of quick notes that we need to write down is if a system of equations has equations that contradict one another, there are no solutions. Okay, so when I say contradict, do you guys know what that means? I hope you know what that means. So when something contradicts, it disagrees. Okay? It disagrees. So when they contradict one another, what we mean by that would be, for example, this one. Okay? So the one that they gave us was supposed to have 480 minutes in it. But the one that we have would have said it would have been 495. So this would be like if we had, for example, if you have one of the equations that says 5g plus 2a equals 165, you had another one that said 5g plus 2a equals 200. This and this match, but these don't. There's no way for the exact same thing to equal both 165 and 200. That's what I mean by when I say contradiction, okay? Or when you have two equations and one says x equals 10 and the second one says x equals 20. Well, it can't be both. That's a contradiction, and it would mean that there are no solutions. So let's go ahead and do some problems with elimination. Now remember, the whole goal with elimination is to try and get to 0. So what do we need to do to get from 3 and -3 to 0? Well, we would have to add those together, okay? So we're going to add across the whole thing. So 3x plus a -3x is 0 x's. And -5y plus a +5y is also 0 y's. And 8 plus a -12 would be -4. Well, this is 0 plus 0, which is 0. Now, does 0 equal -4? No. This is exactly what we mean by a contradiction. Okay? 0 does not equal -4. That is not true. It's a contradiction, so the answer to this one is no solutions. Okay. With this one, this is a little bit trickier because we don't have anything that matches up. So we need to get them to match up. So the way that we do this, I'm going to take this entire top one, and I'm actually going to multiply by a -2. So what I'm doing here is I'm recognizing that there's an invisible 1 here. I need to get from 1 to 2. Now the reason I'm using a negative is because I want to turn this into a positive so that I can just add to -2y. So what that would give us would be a -14x plus 2y equals a positive 42. And now, because these are opposites, that actually helps me. It's easier that way. So we can do 3 plus -14 gives us -11x. Our y's are going to go away. That's going to be plus 0y equals 46. And then we can say -11x equals 46 divided by -11, etc., etc. So I'm not even going to actually finish this problem. But because I was able to do this and get an x, That tells me that there is exactly one solution to this problem. The reason it tells me that, let's back up a little bit here. When we are looking at this problem, we are looking, do these match or are they scaled versions of each other? No. Do these match or are they scaled versions of each other? Yes, but because this one wasn't, it doesn't really matter. Because, yeah, you could times this by -2 to get there. Or just +2, I guess. You could times it by 2 and get to there. But that doesn't hold for this one or this one. So it's not a scaled version of each other. There's no contradiction here. It's not saying anything that would be like, hey, what's the problem? And we know that because of what we did here. We know that there was no contradiction. We were able to get an x value. So without even completing this problem, we know there is one solution. Okay. All right. So last practice problems before your assignment. Jane ordered 2 shakes and 4 hamburgers for $25.98. Hector ordered 1 shake and 2 hamburgers for $12.99. How does Hector's order compare to Jane's order, and what do we do with that? So I want you guys to try this one on your own, okay? I think that you guys can do this one if you will try it. I will post the complete notes on there so you guys can see what I had to say about it. But I think at this point you are ready to go ahead and start your 4.5 practice. Remember that you do need to show your work on that.